So on your screen now is the syllabus that we are going to have for our module number 3, right? So which speaks about the um, Intel 8085 microprocessor architecture first of all. Then we will, in architecture, we will again see the block diagram of 8085 microprocessor and the pin diagram of the processor. 8085 is basically a 40 pin IC. So we will speak about which pin is corresponding to which signal and also. So that comes under the pin diagram. Then we'll speak about the addressing modes, right? In the addressing modes, there are some 5 types of addressing modes which we have in 8085. Okay, that will be followed by the instruction sets. Instruction sets, again, there are 5 different instruction sets are available, which is nothing but all the commands that we have in the microprocessor programming is grouped into in any one of this instruction set. If it does anything related to arithmetic operation, which is kept into an arithmetic instruction set. If it does something on control of some signal to memory or from memory, then it is put as instruction set pertaining to control signals. Likewise, we have got 5 broad categories of instruction sets. Then we'll speak about the interrupts in 8085, and then we will have a few of the basic programming that we can have in the microprocessor 8085, right? So that is what we'll be seeing in the uh, development of assembly language programming. Then we have got 2 types of interfacing, namely memory mapped interfacing and IO mapped interfacing, input, output, and memory. When the interfacing is between the processor and the memory, it is memory interfacing. When it is between input and output devices, then we call it as IO interfacing, right? That is one thing. Then we will look at how decoding of address is done. Then we will go on for the interfacing and programming. Under interfacing and programming, we will have different peripherals which we are going to use as the ICs which aids in the processing of microprocessor, right? Typically 8255, which talks about the programmable peripheral interfaces. Any peripheral device which you connect to your microprocessor will have to go through this interface pin only, 8255. Then you have got another pin 8279, which is for keyboard and display. Okay. And then you have got an pin for IC for interrupt controlling, specifically for interrupt. So that is 8259, right? So these are the 3 interfacing IC is what we will look at each block diagram and how it works and all these things, right? Then we will go on for simple applications of 8085 processor, namely 2 applications only we'll be focusing on, which are namely stepper motor control and traffic light control, right? To be followed by the last part is the introduction part for the 8086 microprocessor. This is on the whole is the syllabus which is available for us for the microprocessor part alone. Okay, so out of the 3 modules, this module holds close to 40% of the marks comes into here. You typically your question number 14 and 15, that is 15 plus 15 marks, right? And you will have two marks in one module, one unit, and another two marks from the first half of the module 3. So you will have 4 2 marks, right? So close to that is your this module. This module is not having any analytical components in this. Unlike the first module where you had K-map and all these things, minimization of Boolean expression, and so this module, module 2, you had analysis and design of synchronous and synchronous sequential circuits, right? So there you had some analytical stuff coming into picture. But this part of module 3 is purely you're going to draw some block diagrams, a pin diagram, and explain it right 4 pages together, right? So easy. This module is one thing which can help you to get maximize your marks, right? So with this intro, let's move on to the module 3. Okay, shall we, or do we have any clarifications that we have with respect to the syllabus? Am I audible? Am I visible? Can some student put the message in the chat box in both the classes? In the chat box.
Sir, okay, sir.
Okay, so okay, fine. In that case, let's move ahead. Coming into the introduction part, we are going to speak about this microprocessor, what it is all about, right? So this microprocessor is a programmable device basically. What it does is it takes up some input from the input devices, and it's going to perform only an arithmetical and logic operations only over the input that it has taken from the IO devices, and it will give you an output. That output is again going to be binary. Input is binary, output is binary. In between operation is only arithmetical logic operation, right? Programmable device that takes input. That takes input is defined as fetch instruction from memory, right? And does some arithmetic logical operation is decoding, right? And produce desired result, that is execute them and give results, right? So there are two definitions which are available. Okay. Now, having said that, what is microprocessor? What it constitutes, it's only three things. An arithmetic and logical unit to do your process of arithmetic and logical things. And there will be a set of register arrays. In fact, it is not register alone, it is a register array. When we say array, it is of some bits, some number of bits available. We will come to know what is the number of bits available in the later classes, right? And there is a separate control unit is also available. Okay. So these are the three basic elements which are available in our microprocessor: an ALU and register array and control unit. Okay. So now what this the ALU does is it does only the arithmetic and logical operations on the data which is received by the memory or an input device, right? And what is this register array? Register array, there are number of registers arrays, like uh, accumulator is one register. Adding to that is some six different registers which are identified by the letters, namely B, C, D, E, H, and L. Each of these registers, when they stand alone, they stand as 8-bit registers. Okay, but at the same time, you can combine these two registers also. That provision is also available. BC pair, HL pair, DE pair. Like when you say BC pair, I'm going to have B register, which is an 8-bit, and a C register, which is an 8-bit. I'm going to combine them as a paired register of BC pair register, and I'm going to use it as a 16-bit register. Okay. For certain applications, I need to have a bit length to be more. In that case, rather than using a single register as an 8-bit, I am now going to use it as a pairing of registers. Thereby, I can use 16-bit registers. Hope I make it clear. You have an accumulator, you have a B register, C register, D, E, H, and L. 7 numbers of registers are available. Out of this, accumulators stand separately, while the other 6 registers can be used separately or as a pair. B and C together as BC pair, D and E together as DE pair, H and L together as HL pair. Okay. So then you have got a control unit. What does this control unit does is there will be a flow of data which is coming from the system, right? From a input device or from a memory. So that flow of data and the instructions will be controlled by this control unit only. When this data has to come inside, from where the data has to come inside, whether the data has to come from an input device or whether the data is going to be fetched from a memory element, all these things will be taken care by the control unit. Okay, is the point clear? Mottama மூணு தான் ALU, register, control unit, right? Keep this in mind. Now, having said this, there are three different components available, right? Microcomputer, microprocessor, and a microcontroller. What is the difference? Right? So the first part when you see about what is a microcomputer is all about is it's a computer with a microprocessor as its CPU, and it also has a memory and IO devices added to it. Okay, so that's your microcomputer. Whereas your microprocessor is a single silicon chip, which in turn has an ALU register circuit and a control unit. Memory element comes as an additional peripheral, not internally, it is not built, right? Okay, when you come to microcontroller, it is again a silicon chip, but that silicon chip which will have a microprocessor, memory, and IO devices. When I said memory is not available inbuilt on microprocessor, which is now inbuilt in your microcontroller. Your memory and your IO all in a single silicon package, it is available as a chip as far as microcontroller is concerned. So there lies the difference between these three components, right? Are we clear? Now, moving on to the basic block diagram of this, you have a microprocessor in between. This is a block diagram of a microcomputer, right? So what this microcomputer has is, as already said, a microcomputer will have a microprocessor. Yes, this is what we said. It's a microcomputer is a microprocessor as its CPU and includes memory and I/O. That's what I have put here. It's a CPU, a memory, and an I/O is available separately. And then execute. So this is the sequence of steps that will be followed as far as this microcomputer is concerned, microprocessor is concerned. Madam, now is it okay? The sequence flow. Now is it okay?
Now it is okay, sir.
Okay, there was a call in between. Okay, fine.
Yes, sir. Yes, sir.
Okay. As I said, that there is a sequence of data flow is followed, which is fetch, decode, and execute. Fetch is nothing but taking the inputs from either from an input device or from a memory device. Fetch from something, right? So that is what we have said here. Microprocessor fetches those instructions from the memory and then decodes and executes those instructions until a stop instruction is reached. When you write a program, right, as a computer science student, you know, when you write a program together and finally you come to a statement where you will put either a halt or an end or something, a stop or an instruction, something like that. So till that particular instruction is available, that sequence is continuously done, right? So that is what is fetching. And later the processed result, which will be in terms of a binary, will be sent to an output device, right? So this is the block diagram of a basic microcomputer is all about, right? Now there are few terms that we should always keep in mind in microprocessor is concerned. Okay, the first term is instruction set, right? Instruction set is nothing but there are lots of instructions that we use for the microprocessor to do some operations, right? For something like moving some data, moving data, an input value to a register, namely for B register, something like that. So commands that we will give, right? Move A comma B, move MB. Okay, so those are what we call it as a instructions, set of instructions that a microprocessor can understand, right? So that is instructions. So then is a bandwidth. Bandwidth is, talks about the number of bits processed in a single instruction, right? Then you talk about clock speed. Okay, clock speed speaks about per second how many number of operations can be performed by the processor. Okay, so that is what is determined by the clock speed, and it is basically expressed in terms of megahertz or gigahertz. Okay, it's sometimes it is also called as clock rate, but commercially we use the term clock speed only, right? Then you have got two other terminologies like word length and data type. Word length, what it speaks about is the width of the internal data bus or the register or the accumulator or the arithmetic and logical unit. Okay. When we say microprocessor is an 8-bit processor, it can process 8-bit only at a time. Okay. So that 8-bit, the word length can range from 4 bits to 64 bits, depending on the type of the microcomputer that going to use, right? So here it is an 8-bit data can be processed at a time by the 8-bit microprocessor, which is 8085. Okay. Then comes the data types. The microprocessor, it has multiple data types that ways it can understand, right? Like binary, BCD, XS3, ASCII, signed and unsigned numbers. All these are the different data types which a microprocessor can understand and work upon the data into ALU. That we use in microprocessor. Now moving into the features as far as microprocessor is concerned, not with respect to not narrowed down to 8085, right? But it's applicable for 85 also, right? First feature is it's cost effective. Yes, of course. The microprocessor chips are available at low price and That's at low cost, right? And at that it's portable. That's the second one of the class, I suppose I am out of it. I suppose I am out of A and B right now, logging in again.
Yes, sir. Yes, sir. Now you log in.
Okay, is the screen visible? Architecture diagram.
Not now. Not now.
Just a minute. Yeah. Can somebody let me know from A and B, is the screen visible?
A and B now it is.
Architecture diagram is what I'm sharing right now.
Yes, yes.
Okay. Okay. I don't know where I just went out of this A and B. So this is the architecture block diagram. Just take a minute to make a copy of.
Excuse me, sir. Actually, for the previous slide itself, it got disconnected, sir.
For this.
No, Pentium. Uh,
For this.
yes, yes, yes.
Oh. Okay. Okay. Fine. Uh,
They are asking continue after terms used in microprocessor.
Continue after terms used in microprocessor. Then all these processes were not visible.
Yes, yes, yes. These were there. You were interrupted in the Pentium that portion.
This part. Okay. Okay. Okay, so this is where we were speaking about the evolution of the microprocessor, right? So it all started with the 80 as the first microprocessor, which has gone through the evolution of the in the technology அப்படின்னு சொல்லியிருந்தோம், right? என்னென்ன term சொல்லியிருந்தோம் அப்படின்னா of course, those were just to have an introduction part of it. Sorry guys, again I got disconnected and now combine joining again. Just a minute, starting to present the screen. Okay. Okay. So I suppose now both the classes are able to see both the screens, right? So okay. I can view from here. Okay. Good. Sorry for the inconvenience, data discontinuity. Okay. 80, 85 and 86 is what we are going to see, out of which 85 is an 8-bit processor, 86 is an 16-bit processor. Both are using the clock speed of 5 megahertz. After that, so many microprocess upgradations happened, and right now you are standing in Pentium, the recent version, and what is on screen is only till P4, which got into 2000, and with a data bit of 64 bits with 1.5 gigahertz of clock speed. More the clock speed, less the time taken for your execution, right? Coming into the main core of our curriculum, which we are going to speak about 85 and 86, right? So here in 85, when I say it is, the following is a configuration. 8-bit is a data bus, 16-bit is the address bus, and the program counter and stack pointer are again 16-bit. We'll come to know what is this program counter and stack pointer when we get into the architecture. And there are registers which are B, C, D, E, HL, 8-bit registers separately. And 85 IC uses only plus 5 volt supply for its power, and it operates at 3.2 gigahertz single phase clock. Okay. And this is your architecture diagram, right? One of the questions that you can expect on your part B, typically on question number 14, is this. Briefly explain the architecture of 8085. Okay. I would just recommend you to take a few minutes to copy down this architecture. Okay. And once after you have copied down, we will come to know what is what are the different blocks of operation, what it happens here, right? Take a few minutes and just make a copy of this architecture. Okay. In the meantime, can somebody let me know whether the earlier part that we have seen, is it clear? What is all about the different processes, terminologies? Was those things clear? Can you drop a message in the chat box? Take a few minutes, copy down the architecture. And once when you are done, let us know so that we'll proceed further. If you're done copying it down, let me know. Shall we proceed?
Give to 3-4 minutes.
Yeah, okay, okay, yes.
Difficult to draw.
Okay, fine. Just a minute, I will connect the power card. Shall we?
Shall we proceed?
Okay, there's a response. Fine. Okay, that screen will be visible to you, architecture part. And as your hands are drawing, just listen, put your ears to the speaker and get to know about what each and every block does. Okay. So here you find some block which is by the name instruction decoder and machine cycle encoding, right? So which is something like a complex, which you can replace that as an ALU, arithmetic and logical unit, right? So this instruction decoding and machine cycle encoding is nothing but operation of your ALU only. So this block is again you can replace that with okay. Now let's now focus on the each and every blocks which are available on this architecture. Okay. So here what you will do is you will gradually first to understand what are the how to draw this architecture and keep in mind is you have something like the complete architecture is splitted into 5 different components. Okay. The first component is this component, your registers component, a register section. Second one is your this one, your accumulator, your temper register, your flags and instruction decoder, ALU. So that is your logical part. Then is your timing control. Then is your interrupt control on the top and your serial IO control. If you can remember this 5 different components, functional components, this 5 is based on the functionality of each and every blocks. So the first block, note down, it is a register section. Second block is ALU section. Third block is the timing control, which is on the bottom. Fourth and fifth are the interrupt and the serial IO, right? So now, coming into the first block, a register section, what my register section has, right? What my register section has, as already said, registers are 7 in numbers. First one is an accumulator, then to be followed by the registers, B, C, D, E, H, and L. Adding to that will be a flag register also falls into picture. Okay. So out of this 8 registers, accumulator, flag, and the 6 different registers, this B, C, D, E, H, and L are the 8-bit general purpose registers. Okay. And these registers can be used as a single register or combination, as we already said. When you combine them, you can use it as a 16-bit registers as pairs, BC pair, HL pair, DE pair. Okay. And the number of general purpose registers, what it gives us an advantage is it gives more complexity, or the flexibility is also more, right? And when you combine them, you can program it as 16-bit. All these things are the flexibility which are available to us, right? And that is, I said, this is with respect to this B, C, D, E, H, and L. When we say accumulator, accumulator is a primary register which you are going to play with in your microprocessor, right? Which is an 8-bit register, okay? And it is extensively used in arithmetic logic, loading and storing of operations, okay? That happens basically in input and output instruction. Whenever you bring something from an input device, you put it in the 6 registers, B, C, D, E, and H, L. When you want to process that value, what you do is you just first bring the data from that 6 registers to accumulator. Whatever you have in the accumulator is one thing that you can use it to perform your ALU. And the end result will also be stored in the accumulator only. So that's why we say accumulator is a very important buffer register. Okay. And then there are flag registers. Yes, flag is also an 8-bit register. Flag flip-flops is what is it written here, which is also an 8-bit. Out of this 8-bit, we are going to use only 5 bits. Okay. What are those 5 bits is nothing but this. So this is your flag register, right? When I say it is an 8-bit, it starts with D0 to D7, right? So each of this bit is assigned with some alphabets inside, right? Your S stands for sign, Z for 0, X or don't care cases. These are undefined, right? When I say out of 8, we are going to use only 5. The 3 which are nothing but D1, D3 and D5 are those are undefined. So they are kept vacant. The D4 is auxiliary carry, D2 is parity flag, and D0 is carry flag. Right. So what is this flags each and everything is, right? So let's first get into the sign flag, D7. Okay. We start to do some operation with the instructions which is available, right? And at the end of doing an operation, if you get a negative value, if your result is a negative value, right? Or otherwise, if your most significant bit, MSB of the result is 1, then what it happens is your sign flag will be set to 1. That's what we have dropped here. Sign flag will be S is equal to 1 whenever the resultant value is negative. When the resultant value is positive, S flag, sign flag will be equal to 0. Is that clear? Sign flag. Okay. Then is our 0 flag. This 0 flag is again the result of an operation which is performed in a microprocessor if it is a 0. If the result is 0, then the 0 flag will be set, or otherwise this 0 flag, this register of D6, bit D6 will be equal to 1. If it is a non-zero value, if the result is a non-zero value, then the 0 flag Z D6 will be equal to 0. Okay. Then, before getting into auxiliary carry, let us finish off this carry and then we'll come to auxiliary carry. Okay. Carry flag, when this will be set is whenever the result has a carry or a borrow. When we do an addition operation, right, we get carry, addition of two numbers, right? And ultimately you get a carry. So when you do a subtraction of two numbers, you get a borrow, right? When the resultant is having a carry or a borrow, then your carry flag CY will be equal to 1. Okay. When the resultant is having no carry, then the CY will be equal to 0. D0 will be equal to 0. Is that clear? What is your sign flag, 0 flag and carry flag? Yeah, now it's unmuted. Present now, still taking some time. So, is A and B able to see the screen?